Hello and welcome to the Kirchoff's voltage law video tutorial. Here we have a 12 volt power supply and a bunch of resistors in a circuit. What we're going to do is we're going to use Kirchoff's voltage law to determine the current through every component and the voltage across every component. Kirchoff's voltage law says that in any loop, the total voltage drop must equal 0. So there's a loop here, there's a loop here, and there's a loop here. So the first thing we're going to do is we're going to define our three loops. So we're going to say that this is loop 1 with a current of I1 traveling through this loop. This over here is loop 2 with a current of I2 traveling through this loop. And this is I3 for our third loop traveling through this loop here. Alright. Kirchoff's voltage law is mostly about setting up the equations and then just working through them, so let's set them up. So we're going to get a 12 volt voltage drop here, which means for the rest of the loop we're going to get a 12 volt voltage drop. So voltage is equal to current times resistance, so we're going to take this 12 here and say that's equal to this current times resistance plus this current times resistance. So let's start with this one. So 3 is the resistance and I1 is the current because there's a current of I1 traveling through this branch right here. So I1. We're going to add it to this current times resistance. Well, the resistance is 1, because 1 ohm. And for this current, there's actually two currents running through this branch. There's I1 traveling the direction of our loop and I2 traveling against the direction of our loop, because our loop is moving clockwise and I2 is counterclockwise. So we're going to say that I1 is the current that is in sync with our loop and I2 is the current that is out of sync with our loop. So the current running through that loop is I1 minus the repelling current, I guess you could say, or the current moving in the other direction. So that's the voltage drop across these two components, because this is V1, or the V across the 3 ohm resistor, and the voltage across the 1 ohm resistor, and that's going to equal this voltage drop here. So that we can say like there's 12 volts in this area and 0 volts in this area. Alright, so next up is our I2 loop. So we'll start with this resistor here, so that has a resistance of 1 times I2 is now in the constructive direction and I2 is in the opposite direction, or say I1 is in the opposite direction. So it's going to be minus I1. So that's moving across here. Now over to this guy. So that's 4 for your R times I2, because I2 is the current running through this branch right here. And now this one's going to be a combination of I2 and I3. I2 is in the direction that the loop is going, I3 is against the direction. So that's going to be 2 for the resistor times I2 minus I3. Whoops. I3. And because there's no voltage supply in this loop, that's going to equal 0. Alright, on to our last loop. Our last loop will start with this one right here, so that's 2. I3 is in the direction of our loop, so that's the positive value. And I2 is against direction. Alright, this is 6 times I3. And there's no voltage supply in this loop, so we're just going to say that's equal to 0. Alright, next thing to do is to take these three equations. Let's put a line here so we can keep track of what's going on. We're going to take these three equations and we're just going to simplify them. So that's 3i1 plus I1 minus I2 equals 12. Next equation is I2 minus I1 plus 4 I2. Whoops. Plus 2 I2 minus 2 I3 equals 0, and the last one, whoops, equals 0. Last one is 2 I3 minus 2 I2 plus 6 I3 equals 0. All right. And what we'll do is we'll put a line there just to keep track. There's going to be a lot of work when we're done, so it's good to keep track of this, be as organized as possible. All right, now what we're going to do is simplify this stuff together. So the first one is 4I1 minus I2 equals 12, and negative I1 plus 7I2 minus 2I3 equals 0. And our last equation is, what I'm going to do is I'm going to space here because I'm going to try to line up my I1s, I2s, and I3s. So negative 2I2 plus 8I3 equals 0. If you want to use matrix math, it's a good idea to do this type of spacing because then you can put this into a matrix, but we will not put it into a matrix. We'll just do a substitution, and we'll cap that, and then we'll start fresh over here. So what we're going to do is we're going to solve this one to see what I1 is equal to in terms of I2, and this one to see what I3 is equal to in terms of I2. And then we're going to plug both those answers into our middle equation, substituting for I1 and I3, so we have a fully I2 equation. So let's see, I'm going to skip some of the math because I got the answers earlier. So the first one is that, let's see, I1 is equal to I2 over 4 plus 3, and I3 is equal to I2 over 4. I got this equation was done by just math from this, and this equation was done by math from this. Okay, so I'll put a line there. All right.